Hi everyone, so we're going to be doing some trig function practice today. Let's go ahead and get started. So, a 6-foot tall person is standing in front of a tree. From eye level, they look up at a 45-degree angle. They're standing 15 feet from the tree. How tall is the tree to the nearest tenth of a foot? So, we want to know how tall the tree is, and then to the nearest tenth when we're calculating. Okay, so that means that we have a person here. Okay. And they're looking at a tree. Well, at the top of a tree. Okay, so we have this tree here. And keep in mind, this person is 6 foot tall. Okay, so from eye level, looking up at the tree, it's 54 degrees. They're standing 15 feet from the tree, and they are 6 feet tall. We want to know how tall the tree is to the nearest tenth of a foot. Go ahead and try to calculate that, and then we'll walk through it. All right, so we are looking up at this tree, or this person is at a 54-degree angle. So going from eye level up to the top of the tree. That is a 54-degree angle. Okay, and then it says they're standing 15 feet from the tree. That means that the distance here is 15 feet. We want to know the height of the tree. So that means that we're concerned about figuring out this value here, right? The height of the tree, we'll call it x. Okay, so given the information that we have and that we've just created this right triangle, we can solve for that height of that right triangle that we just created, right? And in this case, thinking about the fact that 54 is my theta, that means 15 is my adjacent side because it's touching theta as well as the hypotenuse. Remember, the right angle always points to the hypotenuse, which means that this side has to be my opposite. Okay, so looking at what I have in the photo, I know my theta. I know my adjacent side. And I'm looking for my opposite side length. Okay, so thinking about SOH CAH TOA, that means that I should be using TOA, tangent, because that's the one that involves O and A, opposite and adjacent. So when I set this up, I'm going to be saying tangent of 54 is equal to opposite over adjacent. My opposite is x. My adjacent is 15. Now I want to go ahead and isolate x, so I'm going to multiply both sides by 15. Multiply by 15. The 15s cancel each other out. I am just left with x is equal to 15 times tangent of 54 degrees. If we calculate that, we end up with 20.6 about. But notice, remember, it said round to the nearest, the nearest tenth of a foot. Sorry, I thought I'd put a foot for this one. So we're going to have it as 20.6. Hopefully you didn't say that this was your final answer, because we want to know the height of the tree. Remember, this is looking from eye level. So from here to here, it is 20.6 feet. Okay, but we want to know the whole entire length of the tree, how tall it is. Okay, so from here to here, it might be 20.6 feet. But then we also have the remainder of that value that we can still figure out from this point here down to the actual ground, because that's represented by the height of the person. So from there to there is 6 feet. So we're going to take that 6 feet and then that 20.6 that we calculated, and we're going to add them together. So really, the height of the tree is about 26.6 feet. All right, so let's try the next example. Oh my gosh. In all honesty, I don't even know how to edit this out. So, what the heck? How do I back? Oh, that's how you do it. Okay, well, I just figured that out. They updated Screencastify, so that wasn't my fault. All right, example number 2. You are flying a kite with 30 feet of string extended. 30 feet of string extended. The angle of elevation from the spool of string to the kite is 58 degrees. How far off the ground is the kite if you're holding the spool 5 feet off the ground? Okay, so I'll start to draw out this image, and hopefully that'll be enough for you to be able to figure out which of the 3 functions you should be using to solve. Okay, so here's your spool. You're flying a kite. From the spool to the ground, it's 5 feet. Okay, so think about, can you figure out how far off the ground the kite is? All right, so given the information of you're flying a kite with 30 feet of string extended, hopefully you labeled the 30 feet as this side right here. And then if we want to know how far off the ground the kite is, that means that we're going to be looking at this length right here. So that means we're looking for this side length. And then from the spool to the string, we have a degree of 58 degrees. So you should be labeling this angle here 58 degrees. Okay. So given that information, if this is my theta, remember the right angle always points to the hypotenuse. And that means that this makes this side my adjacent, and x is going to be my opposite. Okay, so looking at what we have here in the photo, I know my theta, I know my hypotenuse, and I'm searching for my opposite. So when I'm thinking about SOH CAH TOA, I should be using sine, because that's the one that involves O and H. So I should be saying the sine of 58 degrees is equal to opposite, which is my x, over hypotenuse, which is 30. Okay, I'm multiplying both sides by 30 in order to get x by itself. So crossing off the 30, crossing off the 30. If I calculate using my calculator, 30 times sine of 58 degrees, I end up with 25.4 feet, by rounding to the nearest tenth. If you said that was your final answer, you forgot that what? We are 5 feet off the ground with the spool. X only represents the distance from that kite to where the spool was being held. Okay, so that was 25.4 feet. We, though, want to know the complete distance from the kite to the ground. So that means we're going to take that 25.4 and we're going to add it to this 5 feet that we have the spool at. And combining those two values together tells us that in total, that kite is 30.4 feet above the ground. All right, now I know. Clear, and then hit back. And the last problem, you're flying a kite with 30 feet of string extended. The angle of elevation from the spool of string to the kite is again 58 degrees. But now the question is, let's say that kite fell directly straight down from the position that it held in the air. How far would the kite be from you? So think about how far would you have to walk if you wanted to pick up the kite. Okay. Again, round your answer to the nearest tenth. So hopefully you did a nice little sketch, which would be basically exactly the same as the previous problem. Okay, there you are. Here's the spool. You have a string with your kite that is 30 feet long. And then we've created this right triangle. And then again, from that spool to the ground, it's 5 feet. Okay. We also know that that degree again here is 58 degrees, which is our theta. And notice this time, what we want to know is the distance that you are from the kite if it fell directly straight down, meaning that the distance that we're looking for is the distance from here to here, right? We want to know this distance because if that kite's just falling directly from where it's at above the ground, straight down, that distance would be the same whether you're 5 feet above the ground or directly on the ground. So we really just need to figure out what is this distance here. So again, if this is my theta, this is my adjacent side. The hypotenuse always points to, the right angle always points to the hypotenuse. And then we have our opposite side. Okay, so thinking about what we know, I know theta and I know my hypotenuse. I want to know the length of my adjacent side. So again, thinking about SOH CAH TOA, that means with A and H, I should be using cosine. So cosine of 58 degrees is equal to adjacent over hypotenuse. Adjacent is x, hypotenuse is 30. And then again, we want to make sure that we isolate that x. So I'm going to multiply by 30, multiply by 30. 30 times cosine of 58 is 15.9 feet once we round it to the nearest tenth. Okay. And that is our final answer. Hopefully you did well on these last 3 examples.